Okay, y'all, so today we're going to do probability of compound event notes. The only thing we're doing on this video is this page, and then you're going to move on and work with a partner on the next 2 pages to see how many points you can get by getting the cubes. So the first 2 blanks is probability is the measure of how likely an event is to occur. A compound event combines 2 or more simple events. So a simple event is just like rolling a dice or picking a blue sock out of a drawer and things like that. It's just one event. So compound event is taking 2 of those simple events and putting them together. The probability of an event is the number of desired outcomes, which we talk about is the part, over the number of possible outcomes, which is the total. So literally just part over total. So with probability of compound events, you must know how to identify the event within the situation. So what that means is you need to know what the probability you're finding. So like probability of heads. Okay, and this is just your part. Okay, the next thing is determine the total number of possible outcomes. So how many outcomes you have in total. Understand if the situation involves replacement or without replacement. Meaning replacement, I put it back in. Without replacement, meaning I take it out. So without replacement means the total changes. So total changes. Determine if they are independent, where the total is not affected by the other event, or dependent, where it is affected by the other event. And then multiply fractions and simplify the fractions. So you're going to multiply fractions and simplify the fractions. So remember, and is multiply or equals add. Okay, so those are the 2 things you're going to do. So this says with replacement independent event. So Ladarius has a bag with 2 red. So I'm going to write 2 red, 4 blue, 3 yellow, 1 green. What is the probability of choosing a red tile, replacing it, and means multiply, then choosing a blue tile? All right. So the first thing you're going to do is you're going to write your events. So probability of red times, because it says and, probability of blue. Okay, replacing means that we put it back into the baggie. So I have probability of red times the probability of blue. So I have my 2 fractions. Every action gets a fraction. And we're going to have our part over our total for both. So what is our total? Well, you add up all of your numbers. So 2 plus 4 is 6, plus 3 is 9, plus 1 is 10. So I have 10 total tiles. So 10 goes on both the bottoms because I'm replacing it. It's not, if I pick a red, I put it back and I still have 2 red in there. So my part for red is 2 because I have 2 red out of 10. My part for blue is I have 4 blue out of 10. Okay, so we can simplify these. Okay, so you can either simplify across or you can simplify up and down. So 2 and 10, divide by 2 for both, and that gets me 1/5 times 2 divided by 4, or 4 divided by 2 is 2, and 10 divided by 2 is 5. And then you just multiply straight across. 1 times 2 is 2. 5 times 5 is 25. And that's your answer. So this is independent because the totals did not change. Okay, without replacement, dependent events. Okay, so I have the same thing. You write out 2 red, 4 blue, 3 yellow, and 1 green. And this is Maggie. What is the probability of choosing a red without replacement and means multiply, then choosing a blue tile? Without replacement means the total changes. So I have my 2 fractions. You write probability of red and means multiply the probability of blue. And I have 2 fractions, just like that. So I go off to the side and I add. Oh, well, it's 2 plus 4 plus 3 plus 1 again, so I have 10. Okay, well, I'm not replacing. What happens to my totals? They subtract by 1. So at first I have 10 total tiles, but I choose a red, so I have 2 red out of 10, but I choose a red and I don't replace it, so now I have 1 red. Okay, well then my total changes not from 10 but to 9. So I have 9 on my denominator. Well, how many blue do I have? I have 4 blue out of 9. So now I just reduce. 2/10 divides by 2, and I get 1/5. 1 times 4 is 4. 5 times 9 is 45. And that's my answer. So without replacement means that the bottom number changes by 1 for each tile that she picks. All right, so number 5. With replacement, independent event, same event. Okay? So Eric has a bag with 2 red tiles. So I write 2 red, 4 blue, 3 yellow, 1 green, for a total of 10 colors. Tiles. What is the probability of choosing a blue? So I would write probability of blue. With replacement means that the total does not change. Then another blue. So then means I'm going to multiply another blue. So you do. Every action gets a fraction. I have 2 actions, 2 fractions. Part over total. So my part is, how many blue do I have? 4. Out of how many total? 10. Okay, well, I put that blue back, so I still have 4 blue out of 10 total because I'm replacing it back. Okay, well, 4/10 reduces to 2/5. So I just multiply straight across. 2 times 2 is 4. 5 times 5 is 25. So that is your answer, 4 out of 25. So whenever it's replacement, meaning the total does not change. Okay, last one. Okay, this is without replacement. So dependent events, but it's the same event. So Celeste has a bag with 2 red, 4 blue, 3 yellow, and 1 green for a total of 10 total tiles. What is the probability of choosing a blue? So I would write probability of blue. Not replacing it means the total changes. Or so maybe put a star underneath. Then another blue. So times another blue. Because I'm going to multiply. Every action gets a fraction. So I have 2 actions, 2 fractions. Okay, so I look and I see, okay, it's not replacing. So I know that if I start with 10, I pick a blue, I don't put it back, what's going to happen to my total? It's going to become what? 9. So it starts at 10, and then it will become 9. Okay, so then let's think about our parts. So I have my blue, and it starts with 10 tiles. So how many blue do I have? 4 blue. Okay, but I pick a blue and I don't replace it. So the 4 blue becomes 3 blue. So my top number for my second one is not 4 anymore, but 3, because I took a blue away. All right, so whenever it says not replacing, remember the totals change. So maybe write a note, total change. And then, because I'm picking a blue out, it goes away. So 4/10 times 3/9. So the 4/10 can reduce to 2/5, because I divide both of those by 2. And then 3/9 reduces, 3 divided by 3 is 1, 9 divided by 3 is 3. So now I just multiply straight across. 2 times 1 is 2. 5 times 3 is 15. So 2 out of 15 is your answer. All right, so now what's going to happen is you're going to stop what you're doing. We're going to wait until everyone's done with their notes. And then what you're going to do is you're going to sit there and you can work on your homework, and we're going to go over some of these that have more than 3 events or 2 events and see how that goes. All right, so just hang tight, work on your homework, and then we're going to go on to the next thing.